Hello students, in this video we are going to discuss on certain concepts in thermodynamics. So the first one is thermal equilibrium. So what is thermal equilibrium? According to the definition of thermal equilibrium, it is a equilibrium condition or equilibrium state which is achieved by two or more systems on having been communicated by a diathermic wall. Now, diathermic wall or diathermic boundary is a boundary which allows the heat exchange. So that means if we take two systems, one is a hot system and another system which is cold, that means there is a difference in a heat content between the two systems. Now if these two systems are now connected, are taken in, two objects are in thermal contact now, it's the hotter object and the cooler objects, what will happen, there will be a heat exchange between these two systems, and the heat exchange will takes place up to the time until where no further changes takes place. So heat exchange will stop as soon as the heat content of both the systems are same. So that state is known as the thermal equilibrium state. Now we'll discuss zeroth law of thermodynamics, which is based on thermodynamic equilibrium. Let us consider a system, three systems. The first system is A, the second system is B, and there is a third system, system C. Now system A and system C are in thermal equilibrium, and system B and system C are also in thermal equilibrium separately. Therefore, zeroth law of thermodynamics states that A and B will also in thermal equilibrium. That means A, B, C systems, all of the three systems are in thermal equilibrium with each other. So the zeroth law of thermodynamics states that if two simple systems A and B are each in thermal equilibrium with the third system C, then the systems A, B and C are all in thermal equilibrium with one another. The zeroth law is an experimental observation which forms the basis of the concept of temperature. Therefore, from zeroth law of thermodynamics, we get the concept of temperature. So, the temperature of a system is a property that determines whether or not the system is in thermal equilibrium with another system. Now we are going to discuss about an important concept in thermodynamics, which is thermodynamic variables. Now, what are thermodynamic variables? In thermodynamics, the state of a system at any instant, it represents its condition at that time. Now, this state is specified by a set of experimentally measurable quantities, and these quantities are called variables of the state, or they are simply known as thermodynamic variables. Now, thermodynamic variables are of two categories. One is the intensive variable, and the other is known as the extensive variable. Now, how to distinguish between the intensive variable and extensive variable? Let us consider a homogeneous system which is defined by a parameter y. So, y is the parameter which specifies the system. Now, if we divide the system into two subsystems, the first subsystem is known as the y1 and the second one is y2. Now, if y is equal to y1 is equal to y2, then y is an intensive variable. If y is equal to y1 plus y2, then y is known as the extensive variable. Therefore, we can define intensive variable as those variables which are that means intensive variables are those variable of a system which are independent of its mass or the number of particles present in the system, whereas extensive variables are those variables where the variables are proportional to the mass and to the number of particles present in the system. The example of intensive variables are pressure, density, whereas the example of extensive variables are volume, length, area, and magnetic dipole moment. We have learned about thermal equilibrium. Now we are going to learn about thermodynamic equilibrium. A system has to satisfy certain condition to be in thermodynamic equilibrium. The first is the thermal equilibrium, that is the temperature is equal everywhere. Second one is the mechanical equilibrium, that means no force is acting on the system, that means no work is done. So the system has to be in mechanical equilibrium. The third one is the phase equilibrium. Phase equilibrium means no phase transition is taking place in the system. And the last one is the chemical equilibrium. So in chemical equilibrium, no component change is taking place in the system. So if all these four conditions are satisfied, if a system is in thermal equilibrium, mechanical equilibrium, phase equilibrium, as well as in chemical equilibrium, then the system is said to be in thermodynamic equilibrium. Now, as we have discussed, a system has thermodynamic variables. Now, if the value of the thermodynamic variables which are associated with a system, like suppose we have a system whose variables are P1 and V1. Now if after a certain time it changes from one equilibrium state to another, suppose P2 V2, then the system is said to undergo a thermodynamic process. Now we are going to discuss about this different thermodynamic processes. The first one is the isobaric process. In isobaric process, pressure is constant. If we draw the P versus PV diagram, it will look like this. Second one is the isochoric process. In isochoric process, the volume remains constant throughout the process. If we draw the PV diagram, it will look like this. Next is the isothermal process. In isothermal process, the temperature remains constant throughout the process. And the PV diagram looks like this. So this is the isothermal curve. Next is the adiabatic process. In adiabatic process, no heat exchange takes place, so Q equal to 0. So if we see the adiabatic curve, it looks like this.